Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our decline curve analysis series, and today's topic is going to be brief. It's about simple estimation for stabilization time. All right, so first thing first, we already know that to use or to apply decline curve analysis for a producing well, the well needs to achieve stabilization first, or pseudo steady state condition. And we can estimate the time to reach the pseudo steady state condition using this parameter, stabilization time. Okay, so actually, before you can really apply the decline curve analysis for a specific well, you need to first estimate the stabilization time for that oil well or gas well. Okay, so this parameter is very important, especially if you want to apply decline curve analysis to forecast the production or to estimate the reserve for a specific well. All right, so this video is about stabilization time. All right, so let's read it together. Golan and Whitson provided a very useful rule of thumb for estimation of stabilization time for oil and gas wells. Okay, very interesting. Assuming oil fields develop in 40-acre spacing, okay, 40-acre for oil, and gas fields on 160-acre spacing, then with typical oil and gas reservoir data, the following rule of thumb is applicable for both oil and gas wells. Now it's very interesting because now we have a tool, an estimation for both oil and gas wells. And the tool, the formula, the equation is very simple, fortunately, this one. So we have TS, or the stabilization time, in hours can be estimated with this formula. So TS equals to 2000 divided by K, and K is the permeability in millidarcies. Okay, so it's very simple, straightforward, and handy. You always know, or you must know, the permeability. So if you have the permeability in hand, you can get the permeability. Maybe you can ask the geologist, petrophysicist, or you can also get the estimate of permeability from pressure transient analysis. And thus, now you can estimate the stabilization time. TS is 2000 divided by millidarcies. TS is 2000 divided by the permeability, and the TS you get is in hours. Okay, and lastly, assuming circular drainage area, if you have 40-acre spacing, this is the same with saying that the drainage radius for your well is 227 or 226 meters for oil well. Okay, so for oil field, oil well with 40-acre spacing, in assumption, it equals to the drainage radius for the oil well of 226 or 227 in meters. Whereas talking about the gas, 160-acre spacing, it is the same with saying that the drainage radius for your gas well is approximately 450 meters. Okay, so you can look at this case by focusing on the spacing, the area 40-acre or 160-acre, but you can also view this case in terms of the drainage radius. For oil well, it's around 220 meters, whereas for the gas well, it approximately is 450 meters. Okay, so that's the case for the stabilization time before we can really apply decline curve analysis. Okay, so I think that's all. I hope you enjoyed this video. I hope this short and simple video is useful. Thank you so much, and see you again in the next decline curve analysis videos. Thank you.